All right, my friends, welcome. Let us begin with another video exclusive. Today we are going to go over what we consider to be the product rule. Now look over here. We have been working with things, my friends, like x to the 4, taking the derivative, we get 4x to the 3rd, even stuff like the square root of x, just rewrite it as x to the 1/2 and then take the derivative of that. But my friends, I want you to keep in mind something very serious here, which is, what about a problem to the left here? Well, how would you start this problem? Well, I guess one of the things that we could do is we could distribute this out. All right, we can get negative 4x to the 9, and then we can distribute this with this and get 5x to the 8. This with that, we're gonna get plus 5x to the 4th. Doing that for the remaining ones, we're gonna get negative 12x to the 5th, plus 15x to the 4th, plus 15. Now what we can do is either combine like terms, or we can then take the derivative of everything, right? So maybe combine these together here, and we're going to get negative 4x to the 9 plus 5x to the 8, okay? And then we're going to get plus 20x to the 20x to the 4th, got it? And then we have, I guess, negative 12x to the 5th plus 15. Now we can take the derivative of everything here, get negative 36x to the 8th plus, here we're going to get 40x to the 7th, okay, plus 80x to the okay, so I'll stop here, right? Because if you notice, this is a lot of freaking work to have to do a problem like such. There's got to be some sort of shortcut that says, hey, you see this windy road? Well, guess what? You can just take the slide down over here and just roller skate your way through and not have to go through this huge path. So there's got to be a huge shortcut, and that's what we're going to learn today, my friends. We're going to learn a shortcut to a problem like this where you see these two functions being multiplied together. So let's take a look here. In the very basic sense, look at this problem here, okay? And ask yourself this question. There has to be a more efficient way of doing this. This is where we begin to develop what is known as the product rule. So how can I solve this? Just critical thinking. Well, I know this is x to the 5th, right? Now I can, well, why is it x to the 5th? Just in case, just to review, I guess. Well, this is x times x. This is x times x times x. 5x is being multiplied. X to the 5th, you could just add the exponents. Now, my friends, notice if we take the derivative of this, so if we take the derivative of this, we're just going to get 5x to the 4th. Doing the same problem below, this is going to be x to the 12, and when we take the derivative of that, we'll get 12x to the 11, just bringing it down, subtracting 1. Okay, very simple. Now, we want to keep it simple because we want to develop a trick, something that will allow us to take the derivative of this in a different way and still get 5x to the 4th, right? Because we have these two things that are multiplying. This function and this function are multiplying together. Of course, we can combine them, but there's got to be a shortcut to help us be able to do the problem we just saw up above here, where you have these long parentheses and functions being multiplied. And so we start with the very basics. And to be honest, all you would really do is you would go, okay, let me play around. Take the derivative of the first, okay, times, let's take the derivative of the second. We get 3x squared. Now we're going to get 2 times 3 is 6x to the 3rd. Well, that doesn't match this, so that's not going to work. So let's try something else. Derivative of this, and we keep playing around like this. And if we do, well, we'll develop what's called the product rule. And this is actually what somebody was able to develop by themselves, just playing around with a simple function like this to eventually get 5x to the 4th, and then they verify to see if it worked for everything else. So the product rule ends up going like this, okay? And the way we're going to do it is, well, let's label this right here, the first function, this x squared, we'll label it first. And let's label this over here as second. And the product rule really states this. We're going to take the derivative of the first. So I'll just write derivative of first, just d dx means derivative of first, multiplied by the second. We're going to leave the second, leave second alone. Okay, plus, now we're going to leave the first alone. Okay. And then we're going to take the derivative of the second, like such. Okay, so what does this mean? Well, what this means is, well, let's go ahead and do it, right? We labeled x squared to be first, so take the derivative of the first, which is going to be 2x. and we leave the second alone. So we leave x to the third alone. So we multiply it, we leave x to the third alone, plus now we're going to leave the first alone, which is x squared, and then we're going to take the derivative of the second, which is x to the third, which is 3x squared. Reorganizing this, we're going to get 2x to the fourth plus 3x to the fourth. Adding these, we're going to get 5x to the fourth. And there it is, my friends. You'll notice these two match up here. And so the person who did this said, no, this can't work. Let me try it on this one here. Well, okay, we'll label this x to the fifth as our first, and we'll label this to be our second. Let's try this little rule and see if we get 12x to the 11. Take the derivative of the first and we get 5x to the fourth. Leave the second alone, so I'll leave x to the seventh alone, plus now we leave the first alone and take the derivative of the second, which is 7x to the sixth. Okay, now let's just rewrite this as 5x to the 11, just simplifying this, plus 7x to the 11. Well, we have common like terms, we add them and we get 12x to the 11, and that does match this right here. So it turns out we can just use this little shortcut whenever we have things that are multiplying, and it'll get us the exact same thing, and it'll be so much more efficient when we begin to do problems like this. So let's work on this first. So notice that these are multiplying. We're going to have to use a distributive property if we wanted to do it the long way using algebra 2. But because we notice that there's going to be some kind of multiplication involved, we can use what we call the product rule. So I'll label this the first and I'll label it the second. So take the derivative of the first, so that's negative 3x squared. Leave the second alone, so I'll put parentheses 3x to the fourth minus 2, plus leave the first alone. Okay, now take the derivative of the second, which is 12x to the third. And there it is, my friend. dy dx is equal to, taking the derivative of our function up above is this. And think about how fast that was to take the derivative. Let's try this one. We'll label the x squared as my first, and we'll label this to be my second. So take the derivative of the first, 2x, multiplied by, leave the second alone. Boom. Plus, leave the first alone, x squared, multiplied by, well, the derivative of the second, which is negative 6x. And there is the derivative. Think about how fast this was compared to having to rewrite everything into standard form.